Hello guys, this is CodeNCode and this is video editorial for the problem Great Graphs taken from Codeforces Div 2 round 728C. Problem is from constructive algorithms in the graph category. So let's see what the problem says. So the problem statement is you are given a shortest path length of each node, right? From node 1. Okay, and then we have to assign edges which minimizes the total cost sum, okay, of the edges. Now the graph is directed and it can be it is weighted. The weights can be negative and there are no multiple edges, right? So if I explain this with an example, so this is the input that is given for node 1. The distance of node 1 from 1 is 2, shortest distance we are talking about. This shortest distance from node 1 to 1 is 0. Shortest distance of node 2 to from node 1 is 2, and same shorter distance of node 3 from node 1 is 3. Okay, so this is the only thing that you are given. So now you have to construct a graph. There are many possible constructions, right, of the given graph, and we have to make sure that these all are valid. We have to construct a graph in such a way that the shortest path from node 1 to node 2 should be 2. The shortest path from node 1 to node 3 should be 3, and okay, so this should follow. Okay, and the second thing that we need to take care of, that the overall sum of the edges should be as minimum as possible. For example, for this construction, the sum of edges is weight sum of edges is 5. For this construction, weight sum of edges is only 3, so this is better as compared to this. Is this the optimal solution? The answer is no. The optimal solution is this. The overall sum comes out to be -3, which is much better, and it also is compliant with this. Okay, it is also making sure that these are all valid, like the shortest distance from node 1 to node 2 is 2, shortest distance from node 1 to node 3 is 3. Okay, and then sum of all of edges, if you see, comes out to be -3, so this is the best choice and this is the answer. For this input, the answer should be -3. All we have to do is print the overall sum of the edges of the minimum sum, okay, that you can come up with. So there are many problems like how to construct the graph and how to assign the edges. These are the problems. So we'll see how we will deal with all of these problems. Okay, so let's go ahead and see some of the observation that will help us to solve this problem. So first observation is that because we have to minimize the overall edge sum, right, we will try to add as many negative edges as possible, and keeping in mind that all of the conditions are still met. So this is the first observation. This is pretty straightforward because we have to minimize the overall sum. Now before we move on, I want to tell you guys one more thing, that this is the course that is going on in parallel, geometric algorithm series. Okay, we'll be covering a lot of geometric algorithms in this course. I'll try to make it as easy as possible, so your support is required in this course. When I say support, I don't only mean the views, because what I actually mean is that your constructive criticism and the problem suggestion that you can suggest that we can solve using this, the knowledge of this lecture. These are the problems that we must solve, because of course I'm only a single guy. There are a lot of you, so if you have came across certain problem that can be solved using certain algorithm of this course, of course let me know in the comment section so that we can go through that as well. And also beside that, you can also share me some of the resources from where I can learn and which you believe is a much better choice for certain algorithms. Okay, so that's why I'm saying that your support is required. That is what I mean by your support. So now let's go ahead and see the second observation. So the second observation says that suppose you want to add an edge AB with cost W, then W should be greater than or equals to dB minus dA. Now what are dB and dA? dB and dA are the minimum cost. These are basically input, the input that you are given. Okay, so dB is the minimum length of path from node 1 to node B, and dA is again same, right? So this is given in the input. So W should be greater than or equals to dB minus dA. So let's see what happens if that is not the case. For example, these are all your D array, so D1, D2 and D3. Okay, suppose I wanted to add an edge from 3 to 2, right, from here to here. So theoretically, by observations 2, W should be greater than or equals to 2 minus 3, because D3 is 3 and D2 is D3 is 3 and D2 is 2, and we will check for D2 minus D3. Okay, so it should have been W should be greater than or equals to -1. What happens if you go below -1, right? So let's say I want to add an edge -2. What will happen is that you will create suppose you added an edge -2. Oh sorry, this is from node 2 to node 3 to node 2. Okay, this is start, this is end. So node 3 to node 2, I forgot to add the arrow. So this is from 3 to 2, right? So what would happen is that in your graph you are already making sure that this is 2, right? From node 1, minimum distance of node 2 is 2, minimum distance from node 3 is 3, right? Here you can see. But when you have added this edge, what you can do is you can come from here to here, then here to here. From node 1 you can reach node 3 with 3 costs, and then using this path of -2 you can reach node 2 with 3 minus 2 1 with cost 1. So minimum length path of node 2 will reduce to 1. Now it is not 2, which should have been the case. Now it is 1 if you take this path. Okay, from 1 to 2, 2 to 3, 3 to 3 to 2. If you take this path, the overall path to node 2 is reducing, right? And that should not happen, and that is the reason why db or w, if you are adding an edge ab, then with cost w, then it should be greater than equals to db minus da. Why we are going to add the edges? Since we need to minimize the overall sum. When we can minimize the overall sum? If we add the negative edges. So what we'll do, we'll add any edge ab if and only if db minus da is actually negative, right? For example, this edge we will add because this is negative. We need to add as many negative edges as possible, right? So db minus da will be negative if and only if a is greater than b, right? So your source should have higher value than your destination. Okay, so if source is having higher value than destination, for example this source node 3 is having higher value than destination, which is node 2, then we can add this edge because db minus da will be -2, oh sorry, -1. We can add an edge from with cost either -1 or greater than that, but since we want to minimize that, so we will add db minus da only. Okay, so this is this observation second. If you are not able to understand, just start again and try to understand this, because this is one of the most important observation that will help us come up with the solution. Okay, so now let's move on to this solution, how we'll build the solution. Suppose this is the input, so what you have to do, first of all, sort the input. Okay, after that this is the node 1 is having value 0, node 2 is having value 2, node 3 is having value 3. This is just to show you guys we don't need actually the node array, we only need this input array sorted, right? After sorting, why we are sorting is that because in the previous observation we have seen that your source should have higher value than your destination. I'm talking about di, right? So what we can do is that if you are at ith node, you can add an edge from I to all of the j which is smaller than I, right? So you can add an edge from here to here, you can add an edge from here to here, right? So let me show you an example. Node 1 won't be able to add any edge because there are no nodes before it. Node 2 will be able to add an edge from 2 to 1 with cost what? 0, -2, -2, right? So -2. From node 2 to node 1 there is an edge of length -2. Now this is the only edge this can add. Now node 3 will be able to add 2 edges. What? From 3 to 2 of cost 2 minus 3, which is -1. So this edge of length -1. From 3 to 1 of length 0, -3, -3. So 3 to 1 of length -3, right? Can we add extra? The answer is absolutely no. So we have added all of the possible negative edges, and this is from observation 2, because from observation 2 we know that we can if we are adding an edge AB, then source should have higher value than the destination, and after sorting we can do that. Now your question should be all of the how to make sure that from node 1 there is a path to every other node, and also this our graph is actually valid for this input, right? There's no path from node 1 to node 2 of length 2, right? So what you can do, you can add a simple edge from node 1 to the highest value node. Highest value node is node 3. Add an edge from 1 to 3 with cost 3, whatever is the cost of this node. What will this do? So see here, now there is a path from node 1 to node 3 with cost 3. Okay, now we have added this edge because we will add this edge only to the highest value node, okay, which is 3. So now there is a path from node 1 to node 3 of length 3, right? So at least this is true. Okay, what about the others? See, just by adding this you are actually making sure all of this is valid. How? See here, if you can reach from node 1 to node 3, which is the highest value node, there is an edge from this node to every other node. Why? Because all of the nodes are having smaller value than this, and that's why we would have added a negative edge from this node to every other node, right? So if you can reach from node 1 to that node is already having edge to every other node, and that's why you will be able to reach other nodes as well. But how to make sure that they are actually the minimum distance is actually whatever is given in the input? Well, the way we have constructed it is actually making sure that, see, the minimum cost from node 1 to node 2 should be 2, right? So 3 and minus 1 is 2. How? This is the proof. See, from let's say the maximum value node is node X. Okay, so from here we have added an edge from every other node, let's say A, so the cost of which would have been dA minus dx, right? That is the edge that we are adding. So since this was the source, this is the destination, so destination minus source will be the cost of that edge, right? To reach that node A, you will go from node 1 to node X, and the cost of which will be d of x, and then from node X you will go to that node, whatever node you are trying to reach, which we are calling as A, that would have a cost dA minus dx. So the overall cost would be dA minus dx plus dx, which is dA, and that should have been the minimum cost to reach node A from node 1. So this is the proof, right? And here you see in our graph there is only one positive edge, all of the other are actually negative, and this is your optimal solution. If I show you the code, here it is, here's the solution. This is visible. LLI is long int 64-bit integer. This is the array for input, and this is the prefix array. In fact, you don't even need the prefix array. So yeah, one more thing, because since we are running here, the way I have explained it, it seems like you have to run a nested loop, right? Because for ith node as source, you have to add all of the edges to all the jth node from 1 to I minus 1, right? And that seems like n square algorithm, but you don't actually need that. Why? Let me show you. See, from node 1 we have to add an edge from node 2 and node 1 as well, basically all of the nodes which are appearing before this, right? So basically I would add 0 minus 3 plus 2 minus 3. If you rearrange this, you would get 0 plus 2 minus 2 times 3. Why 2 times 3? 3 is the value of current node that you are going to add. Why 2 times? Because there are 2 elements before it. That's why 2 times you would subtract it, right? So if you are working with the ith node, you would subtract I minus 1 times the value of current node. Okay, and what would you would add? If you see, this is actually prefix sum till I minus 1th position. So this is the contribution of the ith node in the overall answer. So if you go here, that is exactly what I'm doing. So you don't actually need this prefix array. You can do this in using a single variable. I'm just using this so that it is easy to understand for the guy who is reading my code in future. Okay, so we are reading the input. After that we are sorting it. Result is initialized with 0. What we are doing, we are running a simple loop from 1 to n after sorting. Prefix of I is a sum of first I elements, right? Result will be added by what? I minus 1 times value of current node, that is this I minus 1 times value of current node. This will be subtracted from what? Prefix sum of I minus 1. As simple as that. And finally print the result, adding the cost of the nth node after sorting. Why? This is basically this, because we need to add this positive edge, right? And that is exactly what I'm adding here, and there you go. This is the solution. If you still have any doubt, you can ask in the comment section. So yeah, this was all for this lecture. Thank you guys for watching, and till the next video drops, keep coding. Thank you.